Well, ahoy there, mateys. We're jumping into 1.2, which is all about solving multi-step equations. If you thought the first part was fairly straightforward and simple, solving the simple equations, this is only adding one extra step. Not too bad. So what you're going to learn is how to solve multi-step linear equations using inverse equations, very fancy term for solving. And then you will also use this to model real-life problems. So there's a couple of new terms. Not new, you've used them before. One is inverse operations, which we used in the 1.1. So the inverse of adding is subtracting, the inverse of multiplying is dividing, and the other is mean. This is mathematical mean. So that's like the average when you add up a set of numbers and divide by how many numbers there are. So you'll see mean on a few of your questions. All right, let's jump right into some examples. So here's the first one. You'll be solving 2.5 times x minus 13, and it equals 2. And then check your solution when you're done. So take some time right now, use up some wonderful scratch paper, and solve this puppy. Okay, let's walk through it. Hopefully you started by writing the equation out. There it is. The inverse of subtracting 13 is to add 13. And we usually want to take care of the addition and subtraction stuff first, and then we deal with multiplication and division second. And the reason why is because when you solve a problem or write a problem, you have to do the order of operations. When you're working backwards, you kind of do the inverse, the opposite of the order of operations. So normally you do multiplication and division first, then addition and subtraction. When you're solving, it's the other way around. So we're going to start by adding 13 to each side. There it is. And then you're going to be left with 2.5x on the left. And on the other side of the equal sign, you now have 15. So now to get rid of this 2.5, this means multiply. The inverse of multiply is to divide. So you divide each side by 2.5, and 15 divided by 2.5 is 6. Yay! Hopefully that's what you got for your answer. It's also important to be able to check your answer. So to check it, you just plug 6 back into this original equation. 2.5 times 6 minus 13 is indeed 2, which means it's right. Woo! That's how you check it. Okay, let's do another example. So solve this puppy right here. Good luck. Okay, this one's a little trickier. The first thing you want to do, of course, after rewriting the equation on your own paper, before you start moving stuff around, adding, subtracting, you want to combine like terms. So here you have a 9x minus 6x. You can put those together to make them 3x. So first, combine any like terms that you have. So now you got negative 12 equals 3x plus 15. So now what's your next step? You subtract. Hopefully that's what you said. So subtract 15 on each side because we're trying to get this x by itself. So this plus 15 needs to go away. So when you subtract 15 on each side, you now have negative 27 over here. And then you just have 3x here. The 15's gone because you subtracted 15 from 15. Okay, so now our last step is to do what? Yes, we divide it by 3. And when you divide by 3 on each side, this 3x just becomes x. And negative 27 divided by 3 is negative 9. There's our answer. So now we check our answer by plugging negative 9 into our original equations, which I'm covering up. Woo! There we go. So just plug in negative 9 back to the original ones, and you'll find out, oh, that it does indeed work. It's the correct answer. Fantastic. Well done. Okay, now we're going to jump into another example that we can solve two different ways. So there is a property that you learned last year. We talked about it very briefly this year so far. See if you can remember what property we can use to solve this puppy right here. All right, you might have guessed on that one. It's actually the distributive property. So one way to solve this is to use the distributive property. What that is anytime you have a number next to parentheses, you can distribute that thing outside the parentheses. So first rewrite the equation. Distribute the 2. So you have to do 2 times 1. You also have to do the 2 times this minus x, or 2 times x here. So distribute. Rewrite it after you distribute. So now this becomes 2 minus 2x plus 3 equals negative 8. Woo! Move me over here. So now you want to combine like terms again before you start moving stuff around. So on the left, we have 3 terms. This 2 and this plus 3 can be put together to make 5. So now we got negative 2x plus 5 equals negative out. Now you move stuff now that you can no longer combine like terms. So what do we want to get rid of next? Yeah, we want to move this 5. So you're going to do that by subtracting 5 on each side. Then the 5 will be gone on the left side of the equal sign. You're just left with negative 2x equals negative 13. Our final step is to divide by negative 2. When you divide a negative by a negative, you end up with a positive. So x equals 6.5, which again, you can check by plugging in 6.5 into this original equation here. And when you do that, you find out, oh, it works. You get the same thing on each side of the equal sign. Okay, there's another way. For those of you that don't like or remember the distributive property, there is a second way. This works perfectly well. Both of these methods are great methods. Doesn't matter which one you choose. So another way is just to interpret the stuff in the parentheses as kind of its own little thing. So just treat the stuff in parentheses as like its own thing, and then we'll deal with it later. So if you're going to do that, the first thing you're going to want to do is actually subtract 3 on each side. So we're going to get rid of this 3. And that's just going to leave us with the 2 times the 1 minus x here. And then on the right, we have negative 11 now. Okay, now we're still going to just treat the little parentheses as its own thing. So we're going to get rid of this 2. So the way you do that is to divide by 2 on each side. The 2 will cancel out here. So 2 divided by 2 is 1. So that 2 is gone on the left. And now we're just left with that 1 minus x on the left. Negative 11 divided by 2 is negative 5.5. And now we have a much simpler equation that when you solve it, you'll end up seeing that negative x equals negative 6.5, which means that positive x equals positive 6.5, or x equals 6.5. Same answer we got using the other method. So both of these methods work. One is to distribute, get rid of the parentheses first. And the other is basically move stuff around until you're just kind of the parentheses just disappear because that's all that's left on that side. All right, I'm going to try and speed through just so this video is not a million hours long. We got 2 real life examples we're going to go over. So here's one of them. It says, use the table to find the number of miles X you need to bike on Friday so that the mean number of miles biked per day is 5. So we have 3.5 on Monday, 5.5 Tuesday, 0 Wednesday, 5 on Thursday. And the question is, how many do we bike on Friday to have an average of 5? So that's what this mean is right here. You got to find the average. All right. So the first thing you want to do is make sure you understand the problem. So read that over. Make sure you understand that. Then you want to make a plan. So for me, if I'm ever doing an average problem, it's going to be adding some terms up and then dividing to get my final answer. So in this case, we need to add up all these days, and X is our missing one. So we're also going to have the plus X. So it's Monday, Tuesday, Wednesday, Thursday, Friday that we don't know. We're calling X. And when you find the mean, you divide that by how many there are. And there are 5 days, including the one that we're looking for. So we take that, divide by 5, and we need that to equal 5 because that's what we want the mean to be. Okay, so then after you got that, you can combine like terms. So 3.5 plus 5.5 plus 0 plus 5 is 14. So this whole top part becomes 14 plus x divided by 5 equals 5. So what's our next step? Yes, we must divide. We must multiply by 5 on each side because this is divided by 5. So to undo this divided by 5, you multiply each side by 5. These 5s will cancel out, and it will just leave you with 14 plus x on the left. 5 times 5 is 25. So now what do? Yes, we subtract 14 on each side, and you end up getting x equals 11. So we have to bike 11 miles on Friday to have an average of 5 miles per day. Now, you also need to look back and make sure your answer makes sense. In this case, it does. Feel free to read that to see why, if you're not sure. Okay, and now the last example. Your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100. How many people attended the play? All right, so what I'm going to do is actually just give you a little time, get some scratch paper, work this out, see if you can solve it. Good luck. Okay, now here's a recommended way to solve it. So again, always understand what the problem's asking you first. Make a plan. So for me, the plan would be it's a charge per person, and I'm trying to find the number of people. So I have to do $4 per person times X, I will say. That's this ticket price times the number of people. Now they have to pay back a loan, this $400. So it's then 4 times x minus the $400 that they have to pay back, and that equals the profit. It leaves them with $100 profit. So basically we have 4x minus 400 equals 100. Hopefully you got something like that. So to solve it, I add 400 to each side, and you end up getting 4x equals 500 because this 400 disappears over here. Then divide by 4, and you end up getting x equals 125. Therefore, 125 people have to attend the play. Okay, I may have gone very, very fast. Feel free to rewatch this. Also, make sure if you have any questions to ask me during class. And you can also open up Big Ideas, the dynamic classroom, and kind of go through all of this at your own pace if you need as well. All right, good luck, and I will see you in class. Arr!